Have you ever wondered how to find the exact peak of a projectile's path? In mathematics, this turning point is called the vertex. Today, we will learn how to identify this crucial point by analyzing the graph of a quadratic function. The vertex represents the absolute highest or lowest point on a parabola. It is the specific coordinate where the graph changes direction from increasing to decreasing, or vice versa. We represent this unique point with the coordinates h and k. To find the vertex through graphing, we first look at the standard form of a quadratic equation. The values of a, b, and c are the building blocks that dictate where our parabola will sit on the coordinate plane. Before we find the vertex, we locate the axis of symmetry. This is an imaginary vertical line that divides the parabola into two mirrored halves. The x-coordinate of our vertex is always located exactly on this line. Visually, the vertex is always centered between any 2 points that have the same height. If you know 2 points with the same y value, the vertex's x-coordinate will be exactly halfway between them on the graph. The sign of the leading coefficient tells us which way the parabola opens. If that is positive, the vertex is the lowest point. If that is negative, the parabola opens downward, making the vertex the highest point. Let's work through an example. Given the function f of x equals x squared minus 4x plus 3, we first identify our coefficients. Here, a is 1, b is negative 4, and c is 3. Next, we calculate the x-coordinate of the vertex using the formula negative b divided by 2a. Plugging in our values gives us positive 4 divided by 2, resulting in an x-coordinate of 2. To find the corresponding y-coordinate, we plug our x value back into the original function. 2 squared is 4, minus 8 is negative 4, plus 3 gives us negative 1. Our vertex is now fully identified. Now we plot the point 2, negative 1 on our graph. This is the turning point of our parabola. Because our a value was positive, we draw the curve opening upwards from this specific vertex. Let's try one where the parabola opens downward. For the function negative x squared plus 2x plus 1, the axis of symmetry is at x equals 1. Notice how the negative a value will flip our shape. By substituting 1 into the equation, we find the y-coordinate is 2. We plot the vertex at 1, 2. Since that is negative, this vertex represents the maximum value of the entire function. If your graph shows clear x-intercepts, you can find the vertex x-coordinate by averaging them. The vertex is always horizontally centered between the points where the graph crosses the x-axis. You can also verify the vertex using a table of values. Look for the point where the y values stop decreasing and start increasing. The symmetry in the y values around a single point confirms you found the vertex. To summarize, always identify your coefficients first, use the symmetry formula to find the x-coordinate, and then evaluate the function to find the y-coordinate. This process works for every quadratic function. Try this one. For the function x squared minus 6x plus 5, what is the x-coordinate of the vertex? If you calculated negative 6 divided by 2, you found the answer is 3. Mastering the vertex allows you to understand the limits and symmetry of quadratic functions. Whether finding a maximum height or a minimum cost, the vertex is your key. Thank you for watching. Generated by Vision Solve AI.